Okay, these are the 4.4 notes, solving absolute value inequalities. And there's a couple things that you have to just memorize for this lesson. The first is when you're solving an absolute value inequality, if the original problem is less than, then you use and. And remember, we've talked about and before, that that's where the two solutions overlap. Both have to be true to be the solution. And then greater than is an or. So that they don't have to overlap, it's just both solutions there. Another thing that you have to remember, on absolute value equations that we set up a negative side of the absolute value, and we'll have to do that too on these inequalities. But when you set up the negative side of the absolute value, you'll have to reverse the inequality symbol. So let's go ahead and take a look at homework number 1. And this one says the absolute value of x is less than or equal to 5. So because it's a less than, I know it's and. So I'm going to set up two problems here. I've got x is less than or equal to 5, and x is greater than or equal to negative 5. Now there's nothing to solve on those two problems, so I can go ahead and graph my solutions down here. Remember, we don't really know the solutions until we graph those. So when I'm graphing the solutions, I've got a closed circle around 5 and going to the left because that's less than or equal to. And then for greater than or equal to negative 5, it's a closed circle and going to the right. So the only part that we graph on MathLab is this part where they overlap, because and is where they overlap. And remember, to write that overlap, we put x in the middle, just like it's in the middle of these two numbers. We put our small number on the left, our large number on the right, and then we use our less than symbols between. So the solutions are x is less than or equal to 5 and greater than or equal to negative 5. Okay, let's take a look at homework number 3. Again, this one starts out a less than, so we're going to drop the absolute value and go ahead and set up our two problems. Remember, we can drop the absolute value because everything is inside the absolute value. You don't want to do that until you've got everything inside. So we're going to set up the original problem, and then because the original problem was less than, we know it's an and then I've got 2x plus 6 is greater than or equal to negative 8. So I turned the absolute value around, and then I made the 8 negative. So now I'll just solve those two problems. So I'm going to do subtract 6, and I've got 2x less than or equal to 2, divide by 2, and I get x is less than or equal to 1, and we'll do the other side. We'll subtract 6 from both sides, and I've got negative 8 minus 6, which is negative 14. Then I'll divide by 2, and I've got x is greater than or equal to negative 7. So I'm going to graph those down here on my number line. And you'll have to draw this number line out on your paper. MathLab will go ahead and ask you for the solutions, but I would really recommend graphing these before you choose or put the solution in. So I'm going to have greater than or equal to negative 7, so that's going to the right. And then less than or equal to, I really want to do that above here, less than or equal to 1. So again, they're closed circles. That's going to the left. And those two overlap between negative 7 and 1. So that's what we're going to put our solution as. X is between negative 7 and 1, and we'll use our less than or equal to symbols. Okay, now we're ready to do some OR problems here. The reason I know this one's OR is because it starts out as a greater than, so I kind of remember that. Kind of helpful hint here, less than and greater than. That'll help you maybe remember which one's which. So this one's an OR. Everything's inside the absolute value, so I can go ahead and drop that off and solve these. So I've got 4/5 x plus 1 greater than 1, or 4/5 x plus 1 less than -1. Don't forget to switch the sign and switch the symbol, turn it around, and then switch the sign of the answer. So I'll go ahead and solve the first one by subtracting 1. So I've got 4/5 x is greater than 0. Then I would divide by 4/5, and I get x is greater than 0. Do that again on this side, subtract 1. 4/5 x is less than -2. Divide by 4/5, and x is less than, it's -10 over 4, but that reduces to -5 over 2. So now we need to graph those. So these are going to be open circles. And remember, on ORs, you want to graph them over top of each other. So we've got greater than 0, so open circle around 0 going to the right. Less than -5 over 2. -5 over 2, when you divide that, is -2.5. So I know it's between -2 and -3. So it's right here and then to the left. So these have a gap between -2.5 and 0. So the way we write that solution is we just put both answers in. X is greater than 0, or x is less than -2.5. Remember, these don't have to overlap because it's an OR problem and we want all the solutions. It's kind of like if I say to you, it could be brown or black. I don't care. Then you could give me a brown or a black pen. But if I said it had to be brown and black, that means the pen you give me has to be brown and black. Okay, let's take a look at homework number 6. Again, this one starts out as a less than, so I know it's an and problem. So we've got 2x plus 4 over 2 is inside the absolute value, so we're okay to drop it off. Less than or equal to 5, and 2x plus 4 divided by 2 is greater than or equal to, and then I need to change the sign to -5. The reason I'm showing you this one, I want you to remember how to get rid of this fraction. Remember, we can always multiply by the denominator. So I'm multiplying both sides by 2, and that'll get rid of my fraction. So that'll cancel these 2's on the left. 2x plus 4 is less than or equal to 10. And I can do the same thing to this problem over here, times both of them by 2. So I'll have 2x plus 4 is greater than or equal to -10. So now I can go ahead and solve both of these. So I'm going to subtract 4. 2x is less than or equal to 6. And then divide by 2. So x is less than or equal to 3. And then subtract 4. So 2x is greater than or equal to -14. Divide by 2. You get x is greater than or equal to -7. So now we need to graph that and make sure those overlap. So I'm going to do less than or equal to 3 going to the left, and then greater than or equal to -7 going to the right, and that overlaps here in the middle. So x is between -7 and 3. Okay, on homework number 8, this one says the absolute value of 2x plus 3 is less than -5. Remember, any number we put inside an absolute value, it could be -100. 2 times -100 plus 3 less than -5. 2 times -100 is -200. And -200 plus 3 is -197. But the absolute value of -197 is positive 197. And this is not true, because a positive is never less than a negative. So if the absolute value says that it's less than a negative, there's no solution, because it's never true that an absolute value is less than a negative. An absolute value will always be greater than a negative. So when you graph this one, you actually won't have anything on the graph, because remember, our graphs should reflect what our solutions are. In our solution, there aren't any solutions. So therefore, we won't do anything to the graph. Now let's take a look at homework number 13. Now be careful on this one, because it kind of looks like it's just like the one before where it says less than a negative again. But on this one, there's something outside the absolute value, so maybe this one isn't really negative. So the first thing we need to do before we drop that absolute value is put that 16 over on the other side, make it positive 16. So really this problem is 2x minus 5 is less than or equal to -5 plus 16 is 11. So this is a positive one, and so this one's okay, so we have to solve it just like we've been doing. So set up our two problems, less than or equal to 11, and less than is and then we'll do 2x minus 5 greater than or equal to -11. Then we'll solve it. We'll add 5 to both sides, so I'll have 2x is less than or equal to 16. Divide by 2, and I've got 8, less than or equal to 8. Add 5 to both sides here, and I've got 2x is greater than or equal to -6. Divide by 2, and so it's greater than or equal to -3, and this is an and. So let's graph and see if that works here. So they need to overlap, so less than or equal to 8 is going to the left. Greater than or equal to -3 is going to the right. And they do overlap between -3 and 8. So that's what we have to put on our solution. X is between -3 and 8 with less than symbols in between. One thing you do want to keep in mind, if you have an absolute value, let's say 2x minus 4 is less than or equal to 0, let's say. That's an and problem. So I would do 2x minus 4 less than or equal to 0 and 2x minus 4 greater than or equal to 0. I can't do a positive and negative 0. So I would have 2x less than or equal to 4, which when I divide by 2, that's 2. And then add 4 to both sides, so I get 2x greater than or equal to 4. So x is greater than or equal to 2. When I graph that, if I've got, let's say 0 here and 1, 2 here, I would have less than or equal to 2, and then greater than or equal to 2. And remember, since this is an and, they need to overlap, and the only place they overlap is right at 2. So the solution, I can't remember which one this is on the homework, but there is one like this. The solution is just that x equals 2, because that's the only place that they overlap. And the other one that I want you to watch out for is when you have an absolute value that's greater than a negative. So remember we said if the absolute value started out less than a negative, it would be no solution. But since all absolute values will be positive, then if it's greater than a negative, the answer is all real numbers. It means it's all numbers will be greater than a negative. Everything that we put in for x will make the absolute value positive, and all positives are greater than all negatives. So greater than a negative is all real numbers. And so on the number line, let's say this is -10 and 0 and 10, the whole number line would be graphed. So you would color that whole number line in, because the solution is everything, all real numbers. So that concludes 4.4. You can go ahead and get started on your homework.